So ayun. So what I am what I am going to do today is to play recorded lecture or recorded presentation on lesson 3.1. So actually yung recorded discussion ng lesson 3.1 ninyo, nahati na siya sa dalawang parts ng recording. Medyo mahaba na siya. Okay, so anyway, kung titingnan niyo naman ding mabuti yung lesson 3.1, medyo mahaba naman siya talaga. And in fact, the entire lesson topic 3, okay, is in fact parang siya yung parang pinakamahabang segment kasi nung course na to. Pag tinuturo ko siya, ito yung parang isang part talaga na medyo nagtatagal ako. Okay. So ayun, what we're going to what I'm going to do para medyo mas mabilis yung yung pacing natin is yun nga, I'll try to record discussions para may mga parts na pwede kong i-skip during the live session para yung iba sa inyo lang panoorin niyo na lang siya on your own time. Okay? So basically, yung recorded lectures have been posted already dun sa sa inyong YouTube playlist. Nandun na siya, naka-upload na siya dun. Although nagpa-process pa yung second part. Okay. So actually hindi pa tapos yan. May mga parang two parts pa yung lesson 3.1. Okay. Pero sa ngayon, since given yung time natin, we will be just probably be presenting yung first two parts nung recorded presentation natin. Okay? So ayun and then while the presentation is ongoing, okay? You may use the chat box para magtanong. Okay? I'll also use the chat box to insert some comments that I would be to make some comments na gusto kong i-gawin during the presentation kasi it might be na baka feeling ko may nakalimutan ako that part or may naalala ko na may mali ako na isulat and ayun, doon saan natin siya i-correct. Okay, so ayun. So please also watch out for the things that nalalabas sa ninyo sa chat box niyo. Okay? So, naintindihan ba yun? Okay, so without further ado, okay, let's watch the discussion. Okay, monitor ko na lang dito kung merong audio yung monitor ko dito kung merong audio yung ating computer. Wait lang, baka nag-feedback yung ko. Wait lang Inform nyo rin ako pag walang pumapasok na audio sa inyo. Okay? So, sige, let's start. Ayun, kita naman ba yung screen ko? Okay, so I'll play it na, no? Lakas na lang konti yung audio. Ayan. Dito. Okay, so sige. I'll start playing this na. So we now discuss the analysis of Lti systems, okay, using the technique of convolution sum. So in this lesson, we now turn our attention to the analysis of important class of linear time-invariant systems. So in the previous discussions, we have already classified or characterized your discrete time systems. Okay, so one important such, okay, are characterized in the time domain or described in the time domain simply by their response to a unit sample sequence. So in the previous lesson, we have discussed that one way to characterize your system, okay, your system in general, not just the linear time invariant class, but but any system, any. Wait lang medyo mabagal yung connection ko Wait lang. Ayun, try natin ulit So we now discuss the analysis of Lti systems, okay, using the technique of convolution sum. So in this lesson, we now turn our attention to the analysis of important class of linear time invariant systems. So in the previous discussions, we have already classified or characterized your discrete time systems. Okay, so one such important class of those linear discrete time systems are those we consider that is both linear and time in time. Okay, so what I will do here is that such Lti systems, okay, are characterized in the time domain or described in the time domain simply by their response to a unit sample sequence. So in the previous lesson, we have already discussed that one way to characterize your system, okay, your system in general, not just the linear time invariant class, but but any system, any discrete time system. One way to characterize those kinds of system is yung what we call the input output relation. Okay, or the IOR. Okay, so here now that we have boiled down our discussion to a particular class of discrete time system, okay, we will be studying some alternative to the input output relation as a way to characterize your system. Okay, and this characterization is what we consider the impulse response. Okay, So when you say impulse response, okay, when you say impulse response, essentially, response means output. Okay? Response means output. Now, the impulse here actually means the stimulus, stimulus or the input sequence. Okay? The input sequence that cause, okay, that cause the system to have this as the output. Okay? So, ibig sabihin, if you have a system, okay, if we represent a system, our system, okay, as, in particular, this is Lti system, okay, as a block, where there is an arrow going into the block that represents what we call the input signal or the input sequence, x of n. So, this is your input sequence, okay, and an arrow, okay, representing the signal or the sequence that is coming out, okay, that is coming out of the system. So which means that is an output to the system. So we call that as the output sequence, okay, or essentially the response, the system response, okay. So yun yung mga tawag natin sa mga output natin, okay. So essentially, kapag ka sinabi nating impulse response, okay, it means it is the output, okay. The impulse response is the output sequence produced when your input is this, okay. When your input sequence is an impulse signal or a unit sample sequence, which we have defined previously as the delta n, okay. Pag ito yung input or yung stimulus dun sa ating system, the output is termed as the impulse, okay. The output is termed as the impulse response. And we will use a special symbol or a unique symbol para sa impulse response natin. We will use the symbol HN to pertain to the sequence representing your impulse response. Okay? Now, what we're trying to point out here is that itong impulse sequence na to, okay, itong HN na to, okay, would then be an alternative to the input-output relationship. Okay, so our point is HN or the impulse response would be an alternative is an alternative to input-output relationship, okay, in representing, okay, and describing LTI systems. And in particular, LTI systems lang. Okay? Because again, IOR can virtually represent and describe any kind of systems. But H of n, okay, is limited only to LTI systems. Okay? Now, if we're given, okay, if the system now, okay, if the system now is given, or if the system now is represented and described by the impulse response, okay, then we can now compute the output of your system, okay, or we can now compute the output sequence produced when we feed our system with an arbitrary input, okay. So again, ang goal ng analysis, no, tatandaan lang natin lagi, no, ang goal ng analysis of systems, okay, the goal of analysis of systems is number one, okay, to determine the output sequence produced or generated by the system, okay, if fed, okay, if past form yan, if fed by an arbitrary input sequence. Okay? So ang isa sa mga goal ng natin ng analysis of system natin is to actually allow us to compute the output sequence. Okay? To compute for the output sequence. Okay? Produced by your system whenever we are feeding or whenever we are stimulating our system with any arbitrary input. Okay? And in the past lessons, nakita natin kung paano siya gawin with input-output relations. Okay? We are able to see paano ang input-output relations can allow us to compute for the output sequence. Okay? To compute for the output sequence. Okay? Given na meron tayong input sequence. Okay? Yun nga lang ang nabanggit natin with the input output sequence, or the input output relation is that there are times that it actually requires us to compute the output sequence sequentially. Okay? So, although may mga cases, okay, there are cases that this is not actually needed, okay, pero practically, whether the IOR allows us or not, okay, the algorithm that implements the IOR is actually implementing or is actually computing the output sequence sequentially. Okay? Whether nire-require talaga siya nung IOR o hindi. Kasi ganyan, may mga IORs that require you to compute the output sequence sequentially. Ang example niyan is, say for example, y of n equals y of n minus 1 plus x of n. Okay? Kailangan talaga nito sequential ang pag-compute natin ng y of n. Because you would not be able to proceed to, say for example, y of 2 without knowing y of 1. Okay? So, sequential talaga yan. Pero something like y of n plus equals, okay, y of n equals x of n plus x of n minus 1 plus 1/2 x of n minus 2, for example. Okay? May or may not require you to compute. I mean, kung gagawin niyo ito sa papel, hindi niyo naman kailangan talagang gawin ito sequentially. Okay? It is possible that you can actually jump as long as you already know yung input sequence niyo. If you already have your input sequence, okay? Nasa inyo na lahat nung sample values ng input sequence niyo. Then pwede naman kayong tumalon at any n. Okay? Say for example, meron na kayong given na lahat ng values ng x of n niyo. Okay? Then pwede na kayong tumalon for example dito sa kung ano man yung value ng n dito sa sample na to. Then yun na i-substitute nyo dito, and then ito dito. Okay, and then ito dito. Okay. So this actually does not require you to compute the output sequentially. And later on pag-uusapan pa natin tong dalawang types of kasi sa atin dalawang magkaibang classes of Lti systems. Okay. So but essentially, okay, kahit na whether your IOR is this or is this, still pag in-implement niyo yung IOR as an algorithm, okay, it would still compute the output sequentially. Okay? Hindi siya pwedeng tumalon kasi that's the purpose of having an IOR eh. Okay? Ang IOR kasi or ang input-output relation is a description of how the output is computed based on the input signal. Okay? And therefore, pag kinompute niyo siya, sequential talaga siya. Okay, whether or not, kailangan talaga siya. So kumbaga, yung computation sa papel, ibang bagay yun. Yung computation sa as an algorithm, ibang bagay din yun. Okay? So always for algorithm, okay? As an algorithm, okay, outputs are required to be computed sequentially. Okay? So ayun, yun ang formality ng nung IOR. Okay? But the thing is that ang gagawin natin ngayon dito sa lesson sa topic 3 is essentially to come up with ways, okay, on how to actually compute the output um without the use of IOR. Okay? Ang goal natin sa topic 3, okay, which I think I have mentioned in a past discussion, is to come up with an alternative of computing the output sequence, okay, y of n, without using the IOR or the input-output relation. So, paano natin gagawin yun? Ang gusto nating mahanap dito is what we call the solution. Okay, what we call the solution of y of n. Okay, the solution of y of n. Okay? At yung solution ng y of n na yan is mathematically has this form. The output sequence y of n is actually a function, okay, in terms of n. Okay, which means na itong right side ng equation niyo simply contains n as a variable. Okay, it simply this right side simply contains n or the time index as the variable. Okay? So, say for example, example lang to ha. A solution, one solution might be for your y of n might be y of n equals say 4 times 1 minus 0.5 raised to 1 plus raised to n plus 1 u of n. Example lang to. Okay? So makikita nyo dito ngayon, this right side, okay, this right side simply contains n as the variable. Although this is a function. Okay, this is that one is a function. Alam naman natin yung definition ng function na yun eh. Okay, that function is we know that function is equal to 1. Okay, when n is greater than equal to 0, and 0 yan when n is less than 0. Okay? So simply, kahit na pag nagsubstitute ka ng n dito sa function natin na u of n, it will just be either 1 or 0. Okay? So ano ngayon yung magiging value nitong ganitong form ng solution of y of n? Dito, kahit anong n yung ilagay nyo, okay? Say for example, maglagay kayo dyan ng n equals 0 o kaya n equals 1,000. You'd be able to compute for, say for example, y of 0, okay? Or y of 1,000. Or kung kailangan nyo pa ng, say for example, n equals negative 10, makukompute nyo rin yung y of negative 10. Simply by substituting this, and this to n dun sa solution natin. Okay, so ito yung hinahanap or i-attempt nating hanapin dito sa i-attempt nating hanapin dito sa isa sa mga i-attempt nating hanapin dito sa topic 3. Okay, and we have two ways to do that. Okay, we have two ways to do that. So these are the techniques, okay, for the analysis of linear systems. Okay, so actually 3. Kaya lang yung pangatlong technique kasi is actually covered or is actually considered what we call Z-domain. Okay? Z-domain technique. So actually indirect method siya ito. Kasi we're talking here in topic 3, we're talking about techniques that are applicable in time domain. Okay? So ibig sabihin ang dinidilang natin na variable dito is the time index n. Okay? So in that case, kung yun lang yung natin, okay, or yung titingnan natin, then there are two basic methods or two basic techniques. Okay? In analyzing the behavior or response, okay, of a linear system, okay, to a given input signal in time domain. Okay? So, pero tandaan nyo na meron pa tong, i-discuss natin din sa topic 3 yung dalawa, but we'll cover also yung third technique sa next topics natin. Okay? So, the first technique, okay, is a direct solution of the IOR. Okay? So, tinawag na nga natin tong IOR. Okay? Yung IOR natin, tinawag na nating difference equation dun sa ating discussion last time. Okay, so we have already mentioned the name difference equation for this. Okay, and your difference equation has this as the general form. Okay, so tatandaan natin na kapag IOR siya, laging naka-isolate yung output sequence dun sa left side. Okay, and the right side contains, okay, the right side always contains either the past output values, okay, or past output or delayed, ito lang. More appropriately, ang makikita niyo sa difference equation is that sa left side, sa right side ng difference equation is delayed output sequences. Okay. And yung ating input sequences, input sequence and its delayed versions. Yan talaga, yan yung makikita niyo sa difference equation. Okay, so sa right side ng difference equation, makikita niyo yung delayed output sequences. Like for example, yung y of n minus 1, okay, y of n minus 2, and so on. Okay, makikita niyo yun doon sa right side. Okay, tapos ito namang input sequence and its delayed versions, dyan yung makikita yung x of n minus 1, x of n minus 2, okay, and so on. So, yung mga yan ang makikita nyo dun sa sa right side. Yun nga lang, we just take note that lahat yan, okay, lahat ng mga sequences na yan, ito, this, and this, all of the sequences that are involved, okay, in this equation, okay. So, wait, let me write this anew. So, there. So, yun nga, this is the general form of your difference equation or of your IOR. Okay, and kapag this equation is or this difference equation is linear and time invariant, maglalagay tayo ng mga restrictions dun sa mga nandito. Pero before that, as I was stating earlier, ang makikita niyo sa left side, okay, is of course the output sequence. Okay? So yung nasa left side niyan is output sequence. Lagi yan. Lagi siya naka-isolate. The output sequence is always isolated on the right side. Okay? Now on the left side, okay, what you would be seeing are the following. Okay? So nabanggit ko na nga kanina, this is number 1. The delayed, let's use yung isa makita nyo dyan is yung delayed output sequences, which is ito, represented by the first term of your difference equation. Okay, while ang makikita nyo pa dyan is yung input sequence and its delayed versions. Okay, so ito yon. So again, ang pag sinabi niyo delayed output sequences, ang makikita niyo diyan is yung y of n minus 1, y of n minus 2, y of n minus 3, and so on. Tapos kapag naman yung input sequence and its delayed version, so the input sequence is x of n. Okay? Tapos yung mga delayed versions niya is yung x of n minus 1, x of n minus 2, x of n minus 3, okay, and so on. Okay? Now, here's the thing. Although sa isang IOR, hindi lahat 'yan lalabas. Because each of these sequences are multiplied by a coefficient. Okay? May naka-multiply sa kanyang coefficient. Okay? So ito, tsaka ito. Okay? So sa mga delayed output sequences ninyo, meron yang tinatawag na coefficient AK. Okay? So itong delayed output sequence niyo is always multiplied by coefficients AK. So yung AK na yan is actually a vector, okay, of coefficients. Okay? So vector of coefficients yan, yung AK. Okay? Tapos ito namang input sequence niyo and its delayed versions. Meron naman siyang mga coefficients BK. Okay? So again, BK is a vector of coefficients. Okay? Now, collectively, later on, itong dalawang vector of coefficients na to, tatawagin natin itong filter coefficients. Okay? Now, kaya ako sinasabi na minsan yung ibang yung ibang sequences ninyo na nakalagay diyan hindi niyo makikita because their coefficients might be 0. Okay, maaaring ang coefficient nila ay 0. So therefore, 0 times that sequence is of course would make the sequence vanish. Okay? So, yan yung makikita nyo ngayon sa isang difference equation. Okay? Just for brevity. Okay? Minsan itong delayed output sequences natin to. Ginagamit natin yung term diyan na past output values. Okay? So bakit natin ginagamit yung past output values to refer to the delayed output sequences in your difference equation? Mangyayari kasi yan kasi kapag sinubstitute nyo na yung n, okay, say for example, if you're trying to solve this equation for n equals 0, okay, for n equals 0, then yung left side niyo becomes y of 0, which is the present output. Tapos yung mga nasa right side niyo becomes y of -1, y of -2, y of -3, and so on. Okay? Again, depende pa rin sa coefficients nila. So ito ngayon, since with respect to the current time index, okay, or the present time index, these are past values or these are past output values. So kaya kung minsan maririnig nyo ako na I will be referring to this term of your difference equation as the past output values. Okay? So ganun din dito. Okay, ganun din dito. I might sometimes refer to this as the present input value, okay, which I refer to actually xn, okay, and the past input values, which I would use to refer to x of n minus 1, x of n minus 2, x of n minus 3, and so on. Again, for the same reason, no? Pag sinubstitute nyo yung or kapag kinompute natin yung output ng y of n, okay, and say we refer to n equals 0, okay, then this becomes this one becomes x of 0, which is with respect dun sa pinag-uusapan nating time index, this is the present input value. Okay, while ito yung x of pag pinalitan niyo ng 0 tong mga n na to, so yung x of -1, x of -2, x of -3, again with respect dun sa pinag-uusapan nating time index, then these are past input values. Okay, so yun, mas madali kasing sabihin itong mga terms na to. Okay, mas madali itong i-refer lagi sa sa context ng difference equation. So that is why pinapaliwanag natin yung this is the actual na makikita nyo talaga sa difference equation, but this will we will be referring this to mean this. Okay, so ayun. Now in order for us to yun na nga, analyze that system, okay, to analyze that system, we need to solve. Okay, we need to solve this difference equation. And this is something that we will develop in a future lesson. Okay, lesson 2. Ano yata to? 3 ayan, lesson 3.3. So diyan natin de-develop yung pagso-solve nung difference equation na yan. Okay? But in this lesson, we will primarily focus on technique number 2, okay, or the second technique. Okay, so ito, the second technique. By the way pala, nakalimutan, nabanggit na rin na niya dito, no? So, para itong difference equation niyo or yung IOR niyo maging LTI. Okay, para ito maging LTI. Okay? Ang requirement is that yung coefficients AK niyo, especially para maging time invariant siya, di ba? Yung coefficients AK niyo at saka BK niyo, okay, must be constants. They must be constants. Okay? So, dapat constants yan. Kasi otherwise, kung hindi yan constant, say for example, yung AK ninyo at yung BK ninyo, yung iba dyan, magkakaroon ng N. Okay? As a coefficient. Okay? Then, it will turn out na yung system ninyo is time varying. Okay? So, mag-fail na kagad siya dito. Okay? So, yun. Also, again, ang isa pang natin is that a system is linear pag ma-isolate nyo yung bawat term. Okay, so dapat ang makikita lang talaga natin dyan is yung product ng coefficient, constant coefficient at saka nung sequence. Okay, so say for example, A1 times y of n minus 1. Okay, and then A2 y of n minus 2. Okay, and so on. Okay, tapos B1, B0, xn. Okay, B1 xn minus 1, and so on. So yan lang ganyan dapat natin siya makikita with these values of A to be constant. So that makes your system now, or that makes the system described by this IOR to be linear and time invariant. So yun yung requirements natin. So again, we will develop techniques in solving this difference equation in lesson 3.3. Okay. So as I was saying, pag-uusapan natin dito sa lesson na to is the second technique. Okay, which involves the decomposition of the input signal into sum of elementary signals. Okay, now the elementary signals are selected, okay, so that the response of the system to each signal component is easily determined. So pipili tayo ng way to decompose your input signal into elementary signals. So in topic 2, nag-aral tayo ng mga I think this is in lesson 2.1. Nag-aral tayo ng mga elementary signals that we can use in our study of discrete time systems and discrete time signals. So nabanggit natin dyan yung delta n, yung u of n, okay, yung real exponential, yung complex exponential, which will turn out later on na magiging sinusoid. Okay? And so on. So, yan yung mga naaral nating mga elementary signals dun sa sa lesson 2.1 natin. Now, ang gagawin natin is to actually choose. Actually, in practice, okay, in theory pala. Okay, ang ginagamit dito ito, yung delta n at saka itong sinusoid. Okay, and each of which has a different purpose kung bakit natin gagamitin yung delta n at saka yung sinusoid. Okay, so essentially, ang gagawin natin dito sa second technique is that we will decompose your input signal into components, okay, containing containing delta n or sinusoid signal. Okay, and then ang gagawin natin is that each of those components, okay, so ganito para ma-illustrate lang din natin yung second technique. Okay, so again, kung meron tayong LTI system, So this is your LTI system represented as a block. So meron siyang input signal, okay, meron siyang output signal. So sabi natin, pag to merong xn, magpo-produce to ng yn as an output sequence. Ngayon ang gagawin natin itong xn natin is i-ano natin siya, i-breakdown natin siya into components. Okay? So say for example, no, yung components na yon is ano, halimbawa lang to, say A1 A1 X1N, okay? A2 X2N, A3 X3N, A4 X4N. Wala tong kinalaman sa ano sa difference equation yung paggamit ko ng A as a coefficient of X. Wala tong kinalaman doon So baka magano kayo, mag-isip kayo, bakit A na yung coefficient ng X? Wala tong kinalaman doon. Okay. This is actually a different thing. Okay. So ayun. So and so on. Ang sinasabi ko dito is that yung x of n natin, i-break down natin into component signals. Okay? Ngayon, supposedly, no, if this linear, if this system is linear and time invariant, okay, then tandaan nyo, ang isang system that is linear, okay, it follows or it implements, okay? It implements yung tinatawag nating superposition theorem. Okay? And as I discussed this last time, ang pinakamadaling way to describe the superposition theorem is to use the phrase the whole is the sum of its parts. And I'm referring to yung whole dito. Okay, this whole is actually I'm actually referring to the output sequence. Okay? Meaning yung kabuuan or the entire output sequence yn, okay, is determined, okay, by the sum of the parts. The sum of the parts na tinutukoy natin dito is the sum of the components, okay, of the input sequence. So sinasabi natin sa superposition theorem, okay, is that if you actually break down yung input niyo into different components, okay, then supposedly si system niyo, okay, si system niyo would produce, say for example, okay, say for example, ito yung in-input niyo, no, okay, kay system niyo. Supposedly ito, itong input na to, magpo-produce siya ng output kay Y1. Magpo-produce ng output sa system niyo as, say for example, B1, Y1 of N. Again, walang kinalaman to dun sa previous discussion natin kanina, yung paggamit ko ng A at saka B are simply arbitrary choices na ginagamit ko ngayon. Okay? Basta ang sense lang is that when A1 X1 is fed into your system, okay, it produces the output sequence B1 Y1. Okay? When A2 X2, okay, is fed into your system, it produces the output B2 Y2. Okay, and so on. So pag A3 X3, it produces B3 Y3. Okay. Excuse me. Pag A4 X4, it produces B4 Y4, and so on. Okay. Now, here's where the superposition theorem would come in. Okay, so supposedly, yung xn nyo kasi, okay, is the sum, okay, your input signal xn, since ito nga yung mga components niya, then kapag inad ko yung mga components, dapat mabuo si xn, kasi nga components nga siya. Okay, remember the even and odd components. Okay, so yung xn natin is a1, x1n, plus, gano'n lang, para mas mabilis. Okay, so yung xn natin is the sum of ak xk, okay, of n. all case. Okay? So, ngayon, ang YN nyo naman, okay? Supposedly ganito, pagka in-input nyo ng buo, okay? Pag in-input nyo ngayon ng buo, so ito yung unang sinabi natin, no? Unang premise natin, no? Pag isa-isa nyo in-input yung components, si LTI system ninyo would produce these individual output sequences. Okay? So pag isa-isa, okay? If this is the input, ito yung magiging output niya or output sequence niya. If this input is fed, okay, this would be the output and so on. Okay? But if we actually input or if we actually fed the system, okay, with the sum, okay, of the components, okay, supposedly pag linear siya, okay, pag linear yung system niyo, okay, it should produce the signal y of n, okay, as actually the sum of these components. Okay? So dapat mabuo niya yung y of n niyo as the sum of the components. So yun yung tawag nating sum of the components of the input sequence, ito, okay, is the whole. The sum of the parts, ito, okay, is the output sequence, ito. So yun yung binabanggit natin tungkol sa sa approach na gagamitin natin on the second technique. That is, we will break down your signals, okay, into component sequences. And then we will try to input this component sequences, okay, into your system, or we will try to feed this component sequences into your system. And then the output now is determined by actually adding the output sequences generated when these component inputs or component sequences are fed into your system. So again, magwo-work lang yung technique na yon on the premise that your system is an LTI system. Kasi dapat LTI din siya bukod sa linear kasi our components will not just be linearly scaled. Ibig sabihin yung mamumultiply siya ng isang constant. They might be also be delayed. Okay, hindi lang pala might, they will be delayed versions, okay, of some elementary signal. Okay? So, yun yung essence ng second technique natin. Now, baka isipin niyo na ganito exactly yung gagawin natin. Actually, hindi naman siya ganito ka rigorous mathematically. Okay? At step by step mathematically. This is just to demonstrate, to drive the point na ganun yung ginagawa ng second technique. But we will have a more compact way of implementing that kind of implementation do sa system niyo. Okay, hindi naman talaga tayo as in magpo-produce ng components ng XN isa-isa. Okay? And then i-compute natin yung components ng Y isa-isa, i-add natin sila lahat. Well, in the essence, ganun yung mangyayari. Pero, the algorithm is actually more compact as it appears. Okay? So, ayun. So, again, that second technique, okay, requires us to decompose, okay, the signal into sum of elementary signals. So, sabi natin, dalawa yan, no? Delta n at saka sinusoid. At ang paggamit ng delta n at saka sinusoid as your component signals has a purpose. Okay, unahin ko itong sinusoid. The sinusoid actually is used as the component signals kung ang gusto nyong malaman about your system is yung tinatawag natin na kanyang frequency response. Okay? The thing is that pag sinusoid kasi yung component signals niyo, each sinusoid, you can actually have each sinusoid to have a certain frequency, to have a certain amplitude at a certain frequency. Okay, tandaan natin na ang sinusoid has the general form A cosine omega omega t plus theta. Okay, so we can have your sinusoid to have an amplitude, okay, to have an amplitude at a certain frequency. Okay? So ngayon yung ang gusto nating malaman is paano magre-respond yung frequency yung ating system, okay, dun sa frequency na yon na ito yung amplitude. So, kapag ang breakdown na o kapag ang system natin or kapag ang ginawa natin is that we've broken down your input signal into component sinusoids. Okay? We're looking for the frequency response of your LTI system. And that discussion is reserved on a future lesson. Okay? So dito tayo ngayon sa delta n. Okay? So delta n is the impulse sequence or the unit sample sequence. Okay, unit sample sequence. Okay, so no wonder na convenient choice. Okay, convenient choice ang delta n as a way to break down your input signal into sum of unit sample sequences. Okay? Dahil ang gagawin nga natin is that our system would be represented by Hn. Okay? I-represent natin yung system natin with Hn. And again, ano yung Hn? Hn is the impulse response. Okay? Or the response of the system to the input impulse signal. Okay? So medyo magkaka-idea kayo ngayon dito na ganito yung mangyayari. So kung ang input pala natin is delta n at magre-respond drawing tayo ng bagong system. Say ito yung LTI system natin, no? Kaya rin critical dito na LTI system siya. Okay? So again, ito yung input signal niyo, ito yung output signal niyo. So kung mag-i-input pala ako ng A1 delta n, no? So lagyan natin siya ng A0. A0 delta n. Okay? So ibig sabihin, kung linear to, okay, if this system is linear, the system should produce an output of, say for example, B0 H of n. Okay, so again, yung response ng system niyo with delta n should be Hn. Tapos, syempre, baka magbago yung coefficient niya. Okay? And here's the thing. Magpo-produce tayo ng delayed versions nito. Okay? So, say for example, magpo-produce tayo ng delta n minus 1 na may coefficients na A1, delta n minus 2. Okay? Which is yung A2, may coefficient A2, delta n minus 3, which is the coefficient A3, which has the coefficient A3, and so on. Okay? And supposedly, itong LTI system niyo, okay, would produce, unang-una, dahil time invariant siya, okay, kahit i-delay nyo kung ang output niya sa delta n ay Hn, okay, pag dinelay nyo yung delta n as an input, okay, madedelay din by the same amount yung Hn kasi nga time invariant siya. Okay? Tandaan, if the system is time invariant, okay, delaying the input by k samples, okay, delays the output by the same amount. So which means hindi tayo masyadong mahihirapan maghanap ng output nitong delta n minus 1. Okay? Outright, the output of your LTI system for delta n minus 1 is simply h of n minus 1. Okay? It would be simply h of n minus 1. Okay? And then some coefficients b1, say yan. Okay? Ganun dito sa delta n minus 2. Okay? Kung ang output ng system ninyo is h of n, okay, sa delta n na input, then magkakaroon nyo ng h of n minus 2 as an output times b2 as a coefficient. Okay? So dito makikita niyo yung sense of actually producing producing the or using the h of n as a description, as a way to describe your system. Okay, because simply it would be very convenient for us to actually produce the output of your system, okay, to delayed versions of your delta n. So mas madali na nga siyang i-produce. Okay. So supposedly kung linear ito, okay, kung linear ito, and if this is, say for example, your xn, this is your xn, then supposedly ito dapat yung y of n niyo. So dapat yung yung x of n niyo, if your x of n is actually the sum of k delta n minus k, okay, for k equals 0 up to say infinity, halimbawa lang, okay, then ang magiging output dapat ng system niyo, okay, supposedly is the summation of d of 0, delta h of n minus 0, h of n minus 0, I mean h of n minus k, okay, or sorry, b of k pala to, b of k, h of n minus k for k equals 0 up to infinity. Okay, so ibig sabihin isang sequence lang pala kailangan natin i-determine. Ito lang, yung hn lang. Kasi from there, ma-generate natin ito, tsaka to. Ma-generate natin yung the rest na yun eh. Okay? Ang tanong na lang is, how do we break down your signal into this? Paano natin i-break down yung x of n ninyo or yung arbitrary signal ninyo into component unit sample sequence? Okay? So, yun yung point ng lesson natin. Ito yung next point ng next discussion natin, which is the resolution of a discrete time signal into impulses. So, how do we resolve a discrete time signal into impulses? Okay. So, unang-una, we have seen the effects of multiplying, say for example, x of n. Nakita natin yung effect of multiplying x of n with the unit step sequence. Okay? So kung may signal x of n ka, tapos i-multiply mo yun sa u of n, that product, okay, becomes the sequence x of n, okay, when your n is greater than or equal to 0, okay, and that is 0 when n is less than 0. Kasi tandaan natin na ito, okay, itong sequence na to, okay, itong unit step sequence niyo is 1 when n is greater than equal to 0, and 0 yan when n is less than 0. So therefore, whenever your n or your time index assumes a negative value, okay, it makes the entire product sequence 0. Okay, and it becomes the signal xn itself, okay, because xn times 1 is xn when your time index is 0 or positive. So diyan nakita natin yung effect nito. Okay. So what about multiplying your x of n with delta n? Okay. So what about multiplying your xn with delta n? So again, pag maalala natin ang definition nitong delta n niyo is 1, okay, when your n is equal to 0, and 0 siya, okay, 0 siya when n is not equal to 0. Okay, so which means this is simply x of 0 when n is equal to 0. Okay, and 0 siya when n is not equal to 0. So paano naging x of 0? Kasi nga when your n is 0 at yan sinubstitute natin doon, okay, that becomes x of 0. And since when n is 0, this is 1. So x of 0 times 1. Okay, so that becomes x of 0 simply. Kapag yung n nyo 0. Ngayon, kapag hindi naman, your sequence is simply 0. Okay? Or the value of your sequence is 0. Okay? So, which means, no, what if i-delay natin ito, si delta n? Okay, delay natin ng, say for example, tingnan natin yung product na x of n times delta n plus 1. Okay? So again, tandaan natin na itong delta n niyo, okay, this delta n, okay, is ano yan, 1 yan, okay, when your n equals -1, okay, and 0 siya when your n is not equal to -1. Okay? So yun yung definition ng delta n minus 1 natin. Okay? And if that is the case, then yung product na to, yung x of n times delta n minus 1 is simply x of -1 times 1 when n is -1 and 0, okay, when n is not equal to -1. Okay? So, so ayun siya, no? Yun yung nangyayari sa kanya. Okay? So, isa pa, say for example, we now have naman x of n times delta n minus 5. Okay? So, again, take note na yung value nung delta n minus 5 ninyo is 0. Okay, 1. Okay? When n equals 5. Okay? And 0 siya. Okay? When n is not equal to 5. So therefore, yung product sequence niyo, okay, your product sequence, and by the way, these are product sequences, ibig sabihin nito mga vectors pa to. Yung mga, since you're multiplying a vector with a vector, ang sagot dyan is also a vector. So these are what we call product sequences. Product sequences, or which are essentially, since sequence pa yan, these are essentially vectors. Okay, tatandaan natin yan, vectors pa yan. Yung vectors lang natin, naka-compact lang yung niya, yung definition niya. Okay, so pero mamaya i-expand ko din ng konti para maging vector talaga siya. So, going back here, so your delta n minus 5, okay, is, yun na nga, sabi natin is 1, okay, when n is equal to 5, and 0 siya when n is not equal to 5. So therefore, the product sequence, okay, na to, is x of 5, okay, is x of 5, okay, when n is equal to 5, okay, and 0 siya when n is not equal to 5. So, nakakita ba tayo ng may nakikita ba tayong parang general pattern dito? Okay. Kung papansin niyo mabuti, and if you're going to use your power of deduction, okay, in general, if you have x of n times delta n minus k, okay, this product sequence is actually x of k, okay, for n equals k, okay, and 0 siya for n not equal to k. Okay, now ito yung sinasabi ko na siya ay product sequence, no? Product sequence yan kasi naka-vector yan. Okay, say for example ito, itong product sequence na to, this is actually 0, ito product sequence to, 0, 0, 0, then this is x of 0, 0, 0, 0, okay, and so on. Lagyan natin ng 3 dot dito at saka 3 dot dun sa kabila para masabi natin siya ay infinite sequence because we don't know how long xn is. So ayan, so ngayon ito yung arrow natin that represents the value of your sample when n is equal to 0. So yun yung product sequence natin para dito. While for this one, ito, this would be same time indices to, 0, tapos 0, tapos 0, tapos ito, x of -1 na to. Kasi kung ito yung x of 0, okay, this would be x of -1. So itatapat natin siya dyan para may sense tong natin, mga vectors natin. Okay, so since yun nga, when your signal is when the time index of your signal is at -1, then magkakaroon siya ng value na x of -1. Tapos dito, the rest of the values, 0 siya. So 0 siya dito, dito 0 din, 0 din, 0 din, 0 din, and so on. So take note lang din, no? Nagkakaroon siya ng value, okay? When the delay for the delta n is the right delay. Okay? So for example, ang delay dito ay 0. Ang k nyo dito basically is 0 eh. Kung titingnan nyo itong general form na to. Ang k nyo dito is 0. Okay, ito yung k, bale. Okay. So ngayon, magkakaroon lang siya ng value dun sa n equals 0 na na time index. But otherwise, kung hindi siya 0, okay, bawa ito, ang n nyo dito is negative 4, negative 3, negative 2, negative 1, 0 yung value ng product sequence nyo. Same thing dito sa kabila. So, ganun din dito. Dito naman, since your k here is negative 1, okay, magkakaroon lang kayo ng value, okay, magkakaroon lang kayo ng value ng product sequence niyo when n is negative 1. Okay, so ito yun. Ito kasi yung n equals 0. So, if this is n equals 0, n equals negative 1 to, so may value siya dun. Negative 2, negative 3, negative 4, tsaka 1, 2, 3, 4, wala siyang value. 0 siya. Kasi nga, when n is not equal to negative 1, 0 siya. Same thing with this one, yung product sequence na to. So this is 0, 0, 0, 0. So negative 4, negative 3, negative 2, negative 1. Tapos 0. Okay. 1, 2. I'm talking about n n equals 3, n equals 4, then n equals 5. Okay, that is yung k nyo dito, ang delay nyo dito is 5. Okay. You'll have x of 5 as the value of your sample. Okay, and then the rest would be 0 na. So, negative 4, negative 3, negative 2, negative 1, 0. Ito dito talaga yung arrow. So, yan yung mga nabubuo nating nabubuo nating mga product sequences when we multiply x of n with delta n. Okay? So, ito yun, yung sinasabi natin. No. So, if we multiply the arbitrary sequence xn, okay? If you multiply the arbitrary sequence xn with a delayed version of your delta n, okay, what is produced? Okay, what is produced is the product sequence of x of k times delta n minus k. Okay, paanong yung kanina, say for example, yung x of n times delta n minus 5, naging x of 5, susundan ko lang yung form niya, x of 5, okay, times delta n minus 5. Okay. Remember that that hindi natin pwedeng sabihin na na ang value ng signal niyo is ang value ng product na to. Okay, hindi pala arrow ang gagamitin. Equal na pala to. We cannot choose x of 5 as equal dito. Simply. Kasi tandaan nyo, product sequence yung sagot niyan. Okay, dito kasi ginawa ko siyang compact form. Okay? So, dinefine ko yung n, ano yung value ng signal nyo doon sa value ng n na yun. Dinefine ko yung n, ano yung value ng signal nyo doon sa n na yun. Okay? So, ganito yung pagkakasulot ko ng Okay? But essentially, pag isusulat nyo siya as a product form, okay? Ito yung magiging equivalent magiging equivalent form niya. Okay? So, ayun. This is the same thing as saying na you'll have x of k for n equals k and 0 for n not equal to k. Yan yung natin. Ganito ko siya sinulat. Okay? Ganito natin siya ibibigay in the product form. Okay? So, here's the argument here. Now, each multiplication of the signal x of n by a unit impulse at some delay picks out the single value x of k of the signal x of n at the delay where the unit impulse is non-zero. Ibig sabihin, kaya siya tinawag actually na unit impulse sequence. Okay? Yun yung parang pinaka-sense nung pangalan na unit impulse or unit sample, sorry. Mas madali pa lang i-explain to using the name unit sample sequence. Okay. So ito. Unit means 1. Okay. And sample means sample. Okay. Ibig sabihin, the purpose of your unit sample sequence. Okay. The purpose of your unit sample sequence is to take one sample value. Okay. One sample value of your signal. So anything na i-multiply nyo sa isang unit sample sequence, kukuhanan niyo yan ng isang sample value. Okay? Isa dahil unit, okay? At kukuhanan niyo ng sample. Okay? So that's the purpose of actually having your unit sample sequence. So the unit sample sequence takes one sample value of your signal out of the many sample values na meron sa kanya. Okay? So again, what we're trying to say here is that the unit sample sequence decomposes, okay, any arbitrary signal xn into individual samples. Mapaghihiwa-hiwalay natin yung mga samples or sample values ng arbitrary signal ninyo by multiplying xn with delta n minus k. Okay? So yung point na di-discuss ko is actually demonstrated in this graph. Okay? So if this is your if this is your entire xn, okay? Tapos i-multiply niyo siya ng delta n minus k, where ang value ng delta n minus k niyo is 0. Okay? Is 0 for for n not equal to k. So 0 siya for n not equal to k, 0 din siya dito for n not equal to k. Pero 1 siya for n equal to k. So obviously, graphically, pag minultiply niyo ito, tsaka ito, lahat ng mga signals na hindi katapat itong 1 na to. So ito, lahat ng mga signals na to. Yan. Tsaka yan. Lahat kasi ng signals na yan, nakatapat dun sa 0 samples nung delta n minus k ninyo. So kung ito, multiply niyo sa 0, magiging 0 yung product niyan. Yan, magiging 0 yung product nila. So kung ito, multiply mo sa 0, magiging 0 yung product niya. Now what will happen? Itong nag-iisang value ninyo, okay, or itong signal na to, signal sample na to, which is x of k, pag yan, multiply niyo sa 1, okay, ang magiging product niyan is of course, the sample value itself. So that's the graphical explanation of what I am trying to explain earlier. Okay? So that's the decomposition. So meaning kapag meron tayong arbitrary signal, ang kailangan natin gawin is to actually form the product sequences. Is actually first to multiply pala. To multiply x of n. So to decompose, decompose xn to component component samples, okay? Ang gagawin natin is to multiply x of n with delta n minus k. So that you'll have the product sequence x of k delta n minus k. So kung ilan ngayon yung length nitong x niyo. Okay, kung ano yung length nito? Length of x. Ganun karami yung equal yan sa number of product sequences. Dahil again, this is a product sequence. Mamaya makikita niyo naman sa example eh. Okay? So yun. So that's how we decompose now xn to component samples. Okay? So we multiply x of n delta n x of n with delta n minus k. Okay, to form the product sequences x of k times delta n minus k. Okay? So, yun, makakabuo tayo ng ganitong product sequences. Nasaan na yan? Ayan, makakabuo tayo ng mga product sequences na to. Okay? So, kung ilang product sequences ang mabubuo natin, depende kung ano yung length ng x of n ninyo. Kung yan ay finite duration, then you can have finite number of product sequences. Say, for example, kung ang length ng x of n ninyo ay n, then you would have n product sequences. Okay? And say, for example, if the length of your x of n is infinite, so you have an infinite duration x of n, then you will have an infinite number of product sequences. Okay? So, ayan. That's how we decompose, okay, your x of n into its sample values, component sample values. Okay? Now, the second question is now, how do we now go back? Or how do we, tawag natin dun sa part na yun, yung parang pinaka, ano bang tawag natin? Antonym. Pinaka-antonym ng decomposition is, antonym ng decompose natin is synthesis. Okay? So, given naman that we are able to break down your x of n to component samples. Okay? How do we now actually form? Okay, how do we actually form the original sequence? Paano tayo babalik dun sa x of n? So that process is what we call synthesis. Okay, so how do we synthesize x of n from the component samples? Okay? So paano siya ibabalik doon sa component samples natin? Actually, pag tingnan niyo mabuti itong product sequences niyo, magkakaroon kayo ng idea kung paano niyo ibabalik sa x of n. Okay? If you actually add your product sequences, so the sum of the product sequences, pag in-add niyo yung product sequences niyo, okay, that should become your x of n. Babalik kayo dapat sa x of n. Okay? So to answer the question na how do we synthesize x of n from the component samples, we simply add the product sequences. Yun lang. Okay? At yung add the product sequences na yun is actually given by this equation. So recall na ito yung product sequence nyo. X of k times delta n minus k. If you add all of the product sequences that you have formed during the decomposition process, okay, then you would be able to form x of n again. Okay? Galing dun sa mga product sequences niyo. Okay, so the right-hand side of this equation gives the resolution. Okay, yun yung synthesis. Okay. Or decomposition of any arbitrary signal. Ito yung delta k, the product delta k times, the product x of k times delta n minus k is the decomposition. Yung summation operation is the resolution or the synthesis. Okay. So this equation actually serves to show two operations in your signal. Okay? So ayun. So essentially, itong sequence na to, tatawagin natin siya ngayong weighted or scaled. Okay? We will call it as a weighted or scaled sum of shifted unit sample sequences. So, kung weighted siya, okay, ito yun, weighted or scaled sum of shifted unit sample sequences. Okay, yun yung tawag natin ngayon dun sa product sequences natin. So, this is what we will use. This is an alternative term that we can use for your product sequences. X of k, delta n minus k. Okay? So, bakit siya weighted? The weight here actually refers to, yung weight dito, or yung scale, actually refers to x of k. So, yung sample value ninyo is actually the weight. Okay? of the weight of the product sequence. Okay, so yun yung mga terms na gagamitin natin in the future kapag pinag-uusapan pa natin ito further. Okay. Now let's take a look at example 1. Okay, so we're given a sequence, okay, as x of n, which has the following sample values. Okay, we take note that your x of n has a value of 3 when n equals 0. Okay, so we take note that so from there mabe-breakdown nyo na yung mga signal values ng x of n niyo, such as, say for example, x of kung 0 to, negative 1, negative 2, negative 3. So x of negative 3 ninyo equals 2. Tawag natin yung signal value, ha. So we call this as the signal value. Okay, this is the signal or the sequence. Okay, x of negative 3 is a signal value. Okay, so from there, pagka alam na natin yung reference natin, mabe-breakdown na natin yung signal value natin at a certain time index. Okay, so what we will do here is to resolve. Okay, resolve this sequence, okay, into sum of weighted impulse sequences. So ibig sabihin, mag-generate tayo ng component signals, okay, composed of weighted impulse sequences natin. Okay, so as discussed, if we multiply x of n by delta n minus k, okay, so we say that the product sequence is 0, okay, everywhere except at k, okay, where the signal value is xk. Okay, now ito yung sinasabi natin, no. Unang-una, your xn is defined at this delay. Okay, so parang dapat n to, but anyway, okay lang din naman kasi what will happen here is that tama to na your product sequence, okay, is or would be shown for k from negative 3 to 6, kasi this would represent itong range na to or itong interval to, this actually represents the delay in the delta n. Okay, so the delay, the amount of delay or the amount of shift pala, sorry, hindi pala delay kasi may plus tayo, so this is the amount of shift, okay, in delta n. Okay, so for example, dito sa table natin, no, this is the delay for this is the product sequence when your k equals negative 3. Okay, when your k is equal to negative 3, this is the itong naka-highlight na beige na to. Okay, so for k equals negative 2, this will be the product sequence. Okay, for k equals negative 1, and again, tingnan nyo mabuti yung product nila. Okay, this is x of n times delta n, okay, delta n plus 3, okay, which is equal to x of k, or x of negative 3, sorry, x of negative 3 times delta n plus 3. So yung mabubuo nyo, product sequence. So yung product sequence din, ito, yung entire vector na to. Okay, yung entire vector na yan. Okay, so yun yung nabubuo natin. So this is the product sequence for k equals negative p, k equals negative 2, k equals negative 1, k equals 0. Ito. Okay, so again, pansinin natin mabuti kung nasan lang nagkakaroon ng value. For example, for k equals negative 3, okay, yung product sequence natin, meron lang value sa n equals negative 3. Okay, the rest, 0 siya. Okay, when the delay of your delta n, okay, dito, for this one, kapag multiply natin si x of n with delta n plus 2, okay, which is equal to x of negative 2 times delta n plus 2, okay, your product sequence would only have a non-zero value when n equals 2, when n equals negative 2. Okay, the rest, 0 na. Okay, so nakita natin yan kanina. Okay, so when This is the product sequence for k equals 1. Okay? The product sequence for k equals 2. Product sequence for k equals 3. Equals 3. The product sequence for k equals 4. The product sequence for k equals 5. And the product sequence for k equals 6. So, paki-check isa-isa yung mga values dun sa table natin, no? At just don't take my word for it. Tingnan nyo mabuti yung mga nakalagay diyan. Okay? At i-inspect nyo mabuti. Okay? And by the way, again, the table used for this used for generating these images para sa example na to is available as an additional material for you. Okay? Now, so that breaks down now your that breaks down now your sequence xn. Okay, pag pinagsama-sama natin yung idea na nakuha natin from here up to here, that breaks down, okay, breaks down x of n to sum or to weighted sample sequences. Yun, to breaks down to weighted sample sequences. Okay? Now, if you actually add, okay, pag in-add nyo actually yung mga product sequences na generate natin sa taas. Okay? Pag tinry natin siyang i-add. Okay? So, for example, ito yung this is this is your x of negative 2. Sorry, x of negative 3 pa to. X of negative 3, delta n plus 3. Okay, which ang x of negative 3 natin is 2. So, 2 delta n. So, yun yung unang sequence, yun yung unang product sequence na nakuha natin. Okay. Ito naman, this is x of negative 2, delta n plus 2, which is equal to ang value yata ng x of, wait lang. So, para mas convenient, nila ko na yung kopya ng xn dito. Okay, so here, we can see here that kung ito yung x of 0 ninyo, okay, this should be your, so ayun, hindi ko susulat yung iba, no? Basta ito yung x of negative 1 ninyo, x of negative 2, x of negative 3. So, ito nga yung 2 dito. Okay? Tapos itong x of negative 2 nyo dito is 4. So, this is 4 delta n plus 2. Okay? Next dito, okay, is, masyado kasi maliit yung space. So, this is x of negative 1 times delta n plus 1. Okay? Which ang x of negative 1 natin is ito. That x of negative 1. Okay, so therefore this is 0 times delta n plus 1. Okay, and so on. Okay, hanggang sa makarating tayo dito. Okay, which is, this is ang delay dito is k equals 6 eh. So this is x of 6 delta n plus 6. Sorry, minus pala, minus 6. Okay, so this would be delta n, ang x of 6 natin is kung 0 to, this is 1, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, so 3 times delta n minus 6. So yan yung mga product sequences natin. So if you actually add these product sequences, mapapansin nyo na mabubuo natin yung x of n natin. Ayan, ito. It's 2, 4, 0, 3, 5, negative 2, 1, 0, 7, 3. Okay? So, which means na pag in-add natin, okay, according dun sa equation, equation 2, ayan, ito, equation 2, okay, according to the equation 2, okay, mabubuo natin si x of n, okay, if you actually add, okay, x of k, delta n minus k. Yung product sequences natin, okay, for k equals negative infinity up to positive infinity. Okay? But simply in this case, ang k lang naman natin is defined, again, from negative 3 hanggang positive 6. Na-determine natin na yung delays na kailangan natin is from negative 3 to positive 6 owing to the fact that your x of n is a finite duration signal, okay, which is defined in the interval between negative 3 and positive 6. So again, sabi ko nga kanina, yung number of product sequences natin, okay, equals yan sa number of sample values of xn, or equals sa length of x of n. So equal yan sa length of x of n. So since ang length of x of n ninyo base dito is 9, so length of x of n is 9, okay, then ito magkakaroon lang din ng 9 terms. Okay, so yun na nga, 1, 2, 3, 4, 5, 6, 7, 8, 9. Mali ba bilang ko? Parang mali bilang ko 10. Bakit 10? Negative 3 to positive 6. That's, yeah, 10. 10 pala to. Ang length pala niyan ay 10, sorry. Kasi may 0 eh. Ang ginawa ko sa kaya ako nakuha yung 9, it's ginawa ko 6 minus negative 3. Okay? Kailangan pa pala magdagdag ng isa. Okay? Kasi meron nga palang term sa 0. Kasi ano yun, negative 3, ito yun. Ayan, bilangan ito. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, yung length ng x ninyo is 10. Okay, so, mali pala yung ano dito. So, negative 6 minus negative 3 plus 1. So, dapat 10 ito. Okay. So, dapat meron din kayong 10 terms para sa at 10 meron kayo dapat na 10 na product sequences. Okay, so the number of product sequences niyo is 10. Okay, which means itong sum na to would also be a finite sum. Okay, at ito na nga yung sum na yun. Kapag in-express nyo ngayon yan as a sum, the equation 2, if you actually express it as a sum, ito yung lalabas. Okay, so again, our point here is we can use equation 2. Okay, we can use equation 2 to show that any arbitrary sequences can be decomposed into sum of weighted impulse sequences. So, ayun, yun yung importance now of having of knowing, okay, that we can break down or we can resolve your arbitrary sequence into sum of weighted impulse sequences. And again, yung knowledge dito is actually a preparation dun sa ating next na gagawin, which is now to determine now the response or the output sequence, okay, the response of Lti systems to arbitrary inputs. Okay, so I'll continue that on the next recording.
Okay, andiyan pa ba kayo? Sorry. Ayun. So since we have still have 25 minutes pa. Okay. So we'll let's watch partially yung yung second part nung discussion nito. Which now I'll proceed to the discussion would now proceed to the discussion of the convolution sum as an algorithm. Although feeling ko hindi siya abot doon sa part na yun, pero at least masisimulan nyo na masisimulan nyo yung discussion on kumbaga yung parang motivation kung ano yung convolution sum. Okay? So sige, let's listen in.
Now, we will pick up on the discussion that we had on the first part of this video, in which, in this case now, we are now ready to determine the output sequence, okay, or the response of Lti systems when we feed it with an arbitrary input. Okay, the algorithm that we will be studying in this point at this point is what we will call the convolution sum. And I know that you have heard of the convolution sum before, especially in your advanced engineering mathematics course. At napag-usapan yan sa part ng Laplace transform. Okay. That convolution sum, this convolution sum, the algorithm for this convolution sum is actually yung discrete time counterpart nung convolution sum dun sa pinag-uusapan sa advanced math ninyo. So again, if you would try to make sense of this things, no, pag nag-aral kayo again ng signals and systems, pinag-aaralan lang siya on the perspective na you have a continuous time system having continuous inputs and producing continuous outputs. Okay, o kaya meron kang discrete time system na you feed it with discrete time inputs and it produces an output of discrete time sequences. Okay, so ibig sabihin the algorithms, okay, and the representations and everything, the mathematical tools can be actually divided, okay, into tools that deal with continuous functions or continuous time functions, okay, at saka yung mga discrete time tools, yung mga tools that are used for discrete time functions, okay. So yun, so yung convolution sum that we will be talking here is actually the discrete time form, okay. This is a discrete time form of the convolution sum. Okay, so of the convolution sum. Okay. So saan natin gagamitin ang convolution sum? Okay. Ito kasi yung hindi natin diniscuss with this is something that we haven't discussed in your previous at hindi niyo malamang hindi niyo discuss dun sa advanced math niyo, no. Ang convolution sum actually, okay, is used to determine the the response. This is on the perspective or on the standpoint of system analysis. Kasi pinag-aaralan natin ang convolution sum sa advanced math ng as a mathematical tool lang. Okay. For example, ginagamit natin siya to evaluate yung Laplace transform or inverse Laplace transform ng ibang mga functions natin. Okay. But on the standpoint of signal analysis, okay. Ang talagang purpose ng convolution sum is to determine the response of a system, okay, given certain characteristics or certain representation of the system. Yeah, may kulang ako sa sinabi ko. Determine the response of a system given certain representation or characteristics of the system and the input. So the input to be fed to the system. Sa continuous time system. Okay. Actually, pareho lang naman yung terms na ginagamit natin sa continuous saka sa discrete time. So sa continuous time system, kapag ang system ninyo, continuous time system, okay, pag ang system ninyo is described by what we call the impulse response, h of t is considered the impulse response in continuous time. So, ibig sabihin ng h of t ninyo is a continuous function. So, ht is continuous time function. Okay? So, pag may input kayo dyan na x of t, okay, at may output si system niyo ng y of t, then you can find y of t, okay, as the convolution sum, okay, which is the integral of x tau h of t minus tau d tau from, I think this is This is from 0 to t. Okay? This is from 0 to tau equals t. Kasi ang variable of integration natin dito is tau. Okay? So, ganyan yung yung continuous form ng convolution sum ninyo. Okay? Ngayon, sa discrete time, yun yung i-define natin actually ngayon dito. Pero essentially, ganoon pa rin, no? Yung system ninyo is being described by its impulse response, h of n. And now, in this case, your h of n still, okay, both of them tawag dyan, whether you call it in continuous time or discrete time, both of them are called impulse response. Okay? And both of them are actually defined in the same manner. Ang pagkakaiba lang talaga nila is kung paano kung paano na-generate yung impulse response using the continuous form ng delta t. Ito naman, paano na-generate to ng delta n. And of course, kung tutusin, medyo mas madali itong part ng discrete time side natin. Okay? So, ayun. But in any case, pareho lang yung essential yung fundamental principles na ginagamit natin diyan. Okay? So, in this case, tawag sa kanya parehong impulse response. Okay? And ht here is continuous time function. Ito, yung hn natin is actually a discrete time function. Okay? So, again, makukuha natin yung output sequence y of n, a discrete time signal, if we feed this system, okay, being described by h of n, okay, if we feed this system with x of n, okay, so yan yung essence nung convolution sum. So convolution sum exists para sa continuous time at saka discrete time, at ganyan yung pinaka-purpose nung algorithm na yun. Okay. Now, in this case, since we're talking about discrete time, okay, we will use that. Okay, we will use that to compute or to determine the response, the output sequence. Okay, the response here is the output sequence y of n. Okay. So for a relaxed LTI system, okay, so ito isa pang i-emphasize natin ito. So again, LTI systems are described, okay, can be described pala by h of n, by the impulse response. Okay? And you can only use the convolution sum, okay, if that LTI system is relaxed. Okay? What do we mean by relaxed? Okay? Anong ibig sabihin natin sa relaxed system? We take note that that your system, okay, that your LTI system, na-recognize natin ito before. Okay, na-recognize ito before. That your system has memories. May memory yung system niyo. So, kung maalala nyo, kina-classify natin or kina-characterize natin our system as either static or dynamic. Okay? So, actually, whether it's static or dynamic, merong memory yan. Okay? Meron yung certain kind of memory. Okay? And that memory of your system, okay, sa standpoint ng algorithm, kasi sa algorithm, we call it as the system state, the state of the system. Okay, meaning these are internal stuff about your system, okay, which is kept on the system's memory. Okay? Pero yung memory kasi is minsan is used to describe yung hardware component nung ninyo. Okay? But whether you're talking about the hardware or the algorithm collectively tatawagin natin siyang memory. Okay? Pag gumagawa rin naman kayo ng for example ng code. Okay? At especially kapag kayo ay naglo-loop, for example, may mga times na you have to save your one part of your calculation in a variable. So yung ganong practice is actually saving, okay, a value to a memory. Okay, so yung variable na yun is a memory location, okay, which is actually a physical memory location din. Okay? So, yun yung anahin natin. Now, when you say a system is relaxed, okay, itong memory or yung system state or yung state ng system niyo is considered, or in a mathematical standpoint naman, kasi ito sa hardware standpoint ito naman sa algorithm. Sa naman sa mathematical standpoint, tawag natin diyan initial conditions. Okay? So initial conditions yung tawag natin dun sa mga yan. Okay? So whether we call it as the initial condition or the state of the memory or state of the system, okay? A system is relaxed if if these things, the initial conditions, the memory, okay, or the system state is considered to be 0. So sa mathematical standpoint, yung initial conditions yung 0. Okay? Sa memory standpoint or sa state standpoint, it means na walang naka-save or walang naka-save dun sa system niyo. Okay? So when that is the case, okay, we can consider the system to be relaxed. Okay? And again, remember that you can only apply the convolution sum, okay, to find the output for a system, or to find the response of a system given an arbitrary input kapag relaxed yung system niyo. Okay? So ano 'yon? Dapat inherent na kagad sa atin 'yon. Okay? Na we will have to look for the initial conditions or the state of your system or the state of your memory pagka magko-compute tayo ng output using the convolution sum, which dapat naka-state dapat na relaxed siya or 0 siya. Okay? So again, we will use the HN, the impulse response, okay, as the way to find this response or this YN. Okay? So just remember then, additional information about the impulse response is that the impulse response characterizes the Lti system. Okay? Characterizes dahil later on, gagamitin natin ang impulse response to further describe or to further put into perspective yung yung characteristics ng system niyo. Ano pa yung masasabi natin sa kanya? Okay, so ayun. And aside from characterizing your Lti system, it also allows for the computation of the output sequence. Okay? Yun na, yung output sequence YN. Okay? Produced by the system, okay, in response to an arbitrary input sequence. So yung arbitrary input sequence natin, yun yung x of n. Okay? Now, the formula, okay, that gives the response yn of the Lti system as a function of the input signal xn and the unit impulse response hn is called the convolution sum. Okay? And that formula is this. Okay? So yan yung parang pinaka-formula nung convolution sum natin. Now, actually we would not be remembering sa case ng discrete time systems at sa pag-aaral natin ng discrete time systems. We would not be actually remembering, okay, this formula as the formula for the convolution sum. We will actually remember this more of as an algorithm. So kailangan mas matandaan natin siya in terms of the algorithm rather than the formula itself. Okay? So kumbaga, we should recognize the form of the formula or the look of the formula. But when we are to use this formula to actually determine y of n, we will be remembering more of the steps involved in the formula rather than the formula itself. So here are these are some of the terms that we will have to use. In this formula, we say that xn is convolved with hn. Or we also say that yn, ito rin yung term na here we can use this phrase para to describe equation 3. Xn is convolved
with Hn to produce y of n. Yan, isang phrase na applicable yan dun sa equation 3. Okay, also, we can say that y of n is the convolution sum of xn and hn. So these two phrases are correct ways of reading equation 3. Okay? So ayun. And yung mga derivatives ng mga phrases na yan. Okay. So ano yung operations? What are the operations involved in the convolution sum or in the algorithm of obtaining the convolution sum of two sequences? Okay? So the first one is folding. So here, based dito, okay, ang output index kasi natin is n, okay? Our output has an index of n, okay? So therefore, it means that if you are to substitute anything inside this summation formula, okay? You would have to replace n with k. Okay, papalitan mo lahat ng substitute natin sa loob ng formula na to. Okay, has to be replaced with k. Lahat ng n has to be replaced with k. So substitution into 3, okay, requires replacement of the variable n with k. So lahat ng n, okay, ibig sabihin pag nagsubstitute kayo ng x of n dito, lahat ng n nung x of n gagawin yung k. So that it becomes x of k. Okay? So same thing with h of n. H of n. If you substitute h of n here, you have to replace all the n's. Okay? All the n's of h, okay, into k's. Okay? Now what would happen is that so yung h of n niyo, yun yung magiging h of k. Now the first step, what you would do after that is you fold now your h of k. So that's the first step in the algorithm. So you fold now h of k, okay, about k equals 0, okay, to obtain the time reverse or the time folded version of h of k. Okay, so that's the first. Okay, now next step in the algorithm is shifting. Okay, now yung folded h of k niyo, which is now h of negative k, has to be shifted by n of 0. Okay, I'll explain the significance of n of 0 later on. Okay, pero may importanteng role na i-play yung value ng n of 0 sa algorithm natin. Okay, so then this is the n of 0 here is the amount of shift to be done, okay, for h of negative k. Okay, so just remember that if tandaan natin to, since we will be shifting h of k by n0. Okay, so this becomes h of n0 minus k. Okay, we remember lang that if n0 is negative, okay, you're actually shifting your signal to the left. Okay, so kapag yung since this is time reverse this is a time reverse signal already. Okay, time reverse signal already to. So ibig sabihin kapag shift nyo si time reverse signal with a negative shift, okay, with a negative amount of shift, okay, the signal values tend to go to the left. So basically kapag negative yung n of 0 nyo, the shifting is more of an advanced operation. Okay? So the resulting h of n o minus k
is an advanced version of h of negative k. Okay? While kapag naman positive yung NO na yun natin, sinubstitute natin or shift natin, if we shift h of negative k with a positive amount of shift, okay, the sample values tend to go to the right, which means the sample values tend to be delayed. Okay? So, ayun. Tatandaan natin na kapag ang amount ng h on
Okay, class. Good morning. Ayun, no? So, I'll stop the presentation title because malapit na mag 9 o'clock. So, para hindi masyadong alanganin. Okay, and if you have time, naka-post na yung recorded lecture na yan sa YouTube playlist niyo. Hindi ko lang sure kung provided na siya sa inyong so mukhang sorry. Mukhang wala pa. So ayun, so lagay natin anyway, pinost ko na rin 'tong link na to before sa ninyo. Sa Teams natin. Okay, pero ipo-post ko na rin siya sa So gawa tayo ng page dito. So this is a link to YouTube playlist of recordings. Okay, so tingnan natin sa konti dito sa back. Okay, so ayan. So check the playlist out. Nandiyan na yung mga yung dalawang recorded lecture na pinanood natin kanina, nandiyan na siya. So kung gusto niyo tapusin, ayun. Although we'll continue on this sa next meeting. Although baka doon tayo sa mga next na parts. Okay. So ayun, kaya there are parts talaga na may skip natin. But again, kung provided naman yung recorded lecture, pakitingnan naman yung recorded lecture natin. Okay? So para kompleto yung discussion natin at kompleto rin yung idea sa inyo. Okay? So I think we can dismiss the class na. Okay? Thank you for attending today's meeting. I hope to see you sa